Today is the 29th of March 2024. Okay, and we've been doing a lot of trigonometry. We solved a lot of questions. Okay, today I'd like to have another look at circles, circle theorem. This will be our introduction. Okay, but we've done some circle work. We've even used it to solve some questions. Okay, the possible past paper questions we did. We've applied it. So I'm just going to brush over quickly, and then we'll go ahead and do the introduction. Okay. Thank you to everyone who have subscribed. I've seen another subscriber. Thank you so much. Okay. I have to keep on saying this because personally, when I started I had a YouTube account, but I never used it. But when I started as some content, I like the topic, so I'll get attracted and just watch and just leave it there and go. So one time, one of the person who was on his channel, he said subscribe because it helps us stay in the platform and community, because what it meant was the more subscribers you get, the more YouTube allow your content to circulate. I don't know how that is true. Okay, so please, some people don't even know that when you subscribe, it helps other people watch the content. Okay, so I'll have to keep on sharing. Please subscribe, share, like, follow. Okay, I'll appreciate that a lot. And if the account is not yours, please just ask permission before you use somebody's account, or ask somebody to help you open your own account, subscribe, and then when we upload, you also get your notification. I think that is the best one. In the comment section, you see please follow my notes/script. Okay, so for instance, I have a lot of work here today. Okay, a lot of numbers. So if for instance 18.2 all squared, and you hear 18.2, add the square. Okay, please beware of scammers. Okay, just be careful and take care of yourself online. Beware of scammers. Recap. Please watch last video for recap. We did some interesting trick questions. I introduced you to trigonometry questions in 3D. Okay, the other trick questions, I might solve it in some possible past papers, or maybe I might just bring some of them as starters if they are not too long. Today I'll start. I just wanted to go over some of the trick that we did. So this is the application of cosine rule, which is a squared. I wrote the a here and then I thought I'll flip it. So a squared equals b squared plus c squared minus 2bc cos of A. Okay, so now we are supposed to find x, this x length here. If we had two angles, we could have used the sine rule, but because we only had one angle, the appropriate formula we can use here is the cosine rule. Okay, the more you solve it, the more you can see that. So x, then we have cos x, which is 41. So we've done a squared and cos a. Now b squared and c squared are these two lengths here. 18.2 all squared plus 21.3 all squared minus 2b, b is 18.2, c is 21.3, yeah, cos 41. Immediately you apply the set the equation in motion, apply what you have. The rest is calculator work, okay, which I have just done that. S squared, 18.2 all squared, okay, plus 21.3 all squared will give you 784.93. 2 times 18.2 times 21.3 cos of 41 will give you minus 585.14. So the square, x squared, will be, if you subtract this from that, okay, you have 199.79. So x will be the root of 199.79 is plus or minus, but we choose the plus because it's length. If you do that correctly on the calculator, you get 14.13 centimeters, 2 decimal place, 14.1 centimeters, 1 decimal place, 14 centimeters, nearest whole number, or 2 significant figures. Okay, we've been discussing the importance of leaving your answer as you be told to leave in the question. Okay, it normally comes in the last bit, so don't read the question and get stopped. Read it to the end, okay, and as you read, underline the important bits.
Good evening, my neighbors.
As you read, underline the important bits, okay. Example again. Okay, we have a triangle here. Okay, we have x, we have the 3 sides. You can't use the cosine rule here, or you can't use the sine rule here. Okay, so what you can use here is the cosine rule. Okay, so we are going to apply the cosine rule here. So again, the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. Some people, if they're finding cos a, they make cos a the subject, okay, but normally I just like putting it in and then make cos x the subject, which is easier, because assuming you did this side wrong, then everything goes wrong from there. But so cos x here, okay, assuming you made cos x the subject, you are going to have 5.1 all squared plus 10.3 all squared, okay, minus 8.4 all squared. You divide it by 2 times 5.1 times 10.3. Cos x now, 5.1 plus 10.3, okay, all squared, 5.1 all squared plus 10.3 all squared, okay. If you do that correctly on the calculator, okay, cos x now becomes cos x as the angle becomes 61.54 divided by the denominator 105.06, which will give you 0.5831. Okay, so x will be cos inverse 0.5831. Now your angle now, normally angle question is better to leave it to 1 decimal place. So you can have 54.3 degrees 1 decimal place, or 54 degrees to the nearest whole number. Now, today I want to introduce us to circles, but we've done some circle work, a lot of them, okay, but I think it's an upgraded form, a more difficult way, so that we can solve circle questions, okay. We know what the circumference is, we know what the center is, we know what the diameter is, we know what the radius is, we know a chord, a tangent, a sector, a segment, and an arc, okay. But as I do this series, I might even bring it to the starter and show you again, because we have a video on that. So you can go back and recap, or you wait. When I start, as I go along the line, I might do some starters to explain this, okay. Now, O always denotes the center of a circle, okay. A straight line joining two points on the circumference is a chord. So for instance, if you have a straight line from here to there, okay, that is a chord. 2 points on the circumference, okay. So going round the circle, that is your circumference. So if you have a straight line from here to there, is a chord. To a section on the circumference is the arc, okay. So the whole circle is a circumference, but assuming I just want a little bit part of the circumference, that become an arc, okay. If you have two radar and a chord, I just drew this, okay. So from there to there is the radius, and another there to there, and a chord is a point from one side of the circumference to this side, okay. These two can form an isosceles triangle, okay. Now let's quickly go through the theorems, and we'll leave it here for today, and then tomorrow our next video will solve some questions. So the first theorem, angle in a semicircle is 90. We know that. So that is a semicircle. if you extend from one end to the circumference and another end to the circumference, they will form a 90 degrees here, as long as it's a semicircle. Okay, now we've used this to solve questions several times. So if this is A, the angle on the circumference, the angle on the center will be 2A. Okay, so angle of the center is twice the angle of on the circumference. Is that okay? Now the third part. Okay, the angle at D and the angle at C, okay, are the same. Okay, so if this is 30, that will be also 30. So if A, C, B and A, D, B are subtended from the same arc, okay, then the angles are equal. So for example, we have this angle here. Look, we have this angle here and we have this angle here. This angle at B will be equal to this angle here, okay, and that angle at A will be equal to that angle here. Even if this is 30, then that will be 60, because that's a right angle triangle. So this angle 30 at C, this tiny angle here, B, will be equal to the same angle 30. Okay. And I think next video I'll bring more stuff for us to understand these things, because when you are saying this in abstract, it doesn't mean much, but when you bring more questions, then you are able to apply and see the real picture. What is a cyclic quadrilateral? It's a quadrilateral inserted into a circle with 4 vertices. Okay, so in the circle it means the circumference. So for instance, this is cyclic, a cyclic quadrilateral. As long as you can count 4 sections of 8 on the circumference in the same circle, then it's a cyclic quadrilateral. Now the angle on this side plus the angle here should add up to 180. Okay, so the opposite angle, so this angle here, assuming I knew this angle, I can take it from 180 and whatever I get will be this angle. Okay, now the stereo angle, so this is also a cyclic quadrilateral. Okay, now this angle and the angle will add up to 180. Okay, but here the stereo of a cyclic quadrilateral is equal to the opposite interior. So look at it carefully. This angle, the interior ones, will add up to 180. But assuming you extend it further, now we are not talking about the interior angle, we are talking about this angle here. Okay, this angle at A should be equal to the angle. If you want this angle, you should add this both to get 180. So you should subtract A from 180. But if you want the stereo angle, okay, you should is this angle A is equal to the angle A. Okay, so if you extend another one here and you get an stereo angle, that angle here should be equal to the angle inside here. So that is a quick example. So this angle A here is 92. So if you add both, it should add up to 180. Okay, so 92 minus, you subtract it from 180, it gives you 88. So this angle here is 88 here. Okay, but this angle at B here, okay, will be equal to 65 because this and this are opposites. Okay, so the interior angle and then the exterior angle should be the same. Okay, as we solve questions, you understand these things. Okay, now let's go to the next theorem, the sixth one. Okay, now straight line drawn to touch the outside of the circle of a point, that is a tangent. Okay, so if from the center to the circumference, if you draw a tangent, a straight line on that point, this one meets at 90 degrees. Okay, if you take another point on the circumference and you draw it to meet this line here, this TA will be equal to, the length will be the same. Okay, so that will be our seventh theorem, what I just explained. Okay, so that is 90 degrees, but assuming you extend this tangent from the same circle, from the same circumference, and that one also from the same circle, from the same circumference, they will have the same length. Okay, I'm just ignoring the wording so that we can finish within our usual time, and then we'll come back again and Monday. This is an introduction anyway, so Monday we would do a lot of example work for you to our next video will do some more example work for you to understand. Okay, now the last one, TAB should be equal to BCA. Now the angle is always the middle letter. I think I explained this in trigonometry. Okay, so TAB, that angle here, should be equal to BCA, which we saw in the cyclic quadrilateral. So that is the interior, okay, and that is the exterior. So this angle at C will be, the interior angle will be equal to the angle. Okay, so DAC, that one here, will be equal to CBA. So that's also the exterior, and that is the interior. Okay, so far I've taken you through the theorem I know. When we did the first circle stuff, we didn't look at all this, okay, because now we are doing some more higher work for the higher students. Okay, but you still learn a lot if you follow us. Okay, so thank you very much. Please subscribe, share, like, follow, do whatever you can to push us on the platforms. Okay, I appreciate it a lot. Take care of yourself online and beware of scammers. Okay, and please follow my notes/scripts. Okay, very important. Thank you so much for watching my video today, and I'll see you in the next.